purpose of this demonstration is to provide instructions for the determination of the gross calorific value of solid biofuels using a bomb calorimeter. This demonstration is in compliance with the European standard EN 14918.
Oxygen bomb calorimeter consists of the oxygen combustion vessel or oxygen bomb, the calorimeter jacket with its cover, the oval bucket, the crucible, and other accessories. The ancillary pressure equipment consists of a pressure regulator to control the filling of the bomb with oxygen, a pressure gauge to indicate the pressure in the bomb, and a relief valve or bursting disc operating at 3.5 megapascal and installed in the filling line to prevent overfilling the bomb. A balance for weighing the sample, fuse, etc. with a resolution of at least 0.01 milligrams is preferable and is recommended with a sample mass in the order of 0.5 grams or less. The ignition or fuse wire is constructed with nickel chromium 0.16 millimeter to 0.20 millimeter in diameter. Samples for the determination of calorific value shall be sampled in accordance with EN 14778 and shall be received in the laboratory in sealed airtight containers or packages. Unscrew the head cap of the vessel and set the vessel head on the support stand. Fasten a 10 centimeter length of fuse wire between the two electrodes. Place the fuel capsule with the weighed sample in the electrode loop. Bend the wire downward toward the surface of the charge. Add 1.0 millimeter of distilled or deionized water in the bottom of the vessel from the pipette. Moisten the sealing ring with a bit of deionized water. Slide the head into the cylinder and push it down as far as it will go. Set the head cap on the cylinder and turn it down firmly by hand to a solid stop. Slide the connector onto the inlet valve body and push it down as far as it will go. Close the outlet valve on the vessel head. Open or crack the oxygen tank valve not more than 1/4 of a turn. Open the filling connection control valve slowly and watch the gauge as the vessel pressure rises to the desired filling pressure. Close the control valve. Release the residual pressure in the filling hose by pushing downward on the lever attached to the relief valve. Fill the calorimeter bucket by first tearing the dry bucket on a solution or trip balance. Add 2,000 grams of water. Set the bucket in the calorimeter. Attach the lifting handle to the two holes in the side of the screw cap. Partially lower the bomb in the water. Push the two ignition lead wires into the terminal sockets on the bomb head. Lower the bomb completely into the water with its feet spanning the circular boss in the bottom of the bucket. Remove the lifting handle and shake any drops of water into the bucket and check for gas bubbles. Set the cover on the jacket. Turn the stirrer by hand to be sure that it runs freely. Slip the dry belt onto the pulleys and start the motor. Turn on the digital thermometer. Let the stirrer run for 5 minutes to reach equilibrium before starting a measured run. At the end of this period, record the time on the timer of the digital thermometer and read the temperature. Read and record the temperatures at 1-minute intervals for 5 minutes. At the start of the 6th minute, stand from the calorimeter and fire the bomb by pressing the ignition button and holding it down until the indicator light goes out. Measure the time required to reach 60% of the total rise by estimating the temperature at the 60% point and observing the time when the temperature reading reaches that point. Take the temperature readings at 45, 60, 75, 90, and 105 seconds after firing and interpolate between these readings to identify the 60% point after the total rise has been measured. After the rapid rise, period, about 4 or 5 minutes after ignition, record temperatures at 1-minute intervals until the difference between successive readings has been constant for 5 minutes. After the last temperature reading, stop the motor. Remove the belt and lift the cover from the calorimeter. Wipe the thermistor and the stirrer shaft with a clean cloth. Set the cover on the support stand. Lift the bomb out of the bucket. Remove the ignition lead wires. Wipe the bomb with a clean towel. Open gradually the knurled knob on the bomb head to release the gas pressure before attempting to remove the cap. After all pressure has been released, unscrew the cap. Lift the head out of the cylinder and place it on the support stand. Examine the interior of the bomb for soot or other evidence of incomplete combustion. Wash all interior surfaces of the bomb with a jet of distilled water and collect the washings in a beaker. Remove all unburned pieces of fuse wire from the bomb electrodes. Straighten them and measure their combined length in centimeters. Subtract this length from the initial length of 10 centimeters and enter this quantity on the data sheet as the net amount of wire burned. Compute the net corrected temperature rise by substituting in the following equation. The derived calorific value for the biofuel is the gross calorific value at constant volume. Calculate the gross calorific value at constant volume from the individual experiment by substituting into the following equation. The contribution from the combustion of the fuse wire is given in the following equation. As the moisture content of the actual analysis sample is of interest merely in connection with a calculation to the other bases, it is recommended to calculate a value of the gross calorific value at constant volume for the dry fuel, using the following equation. The calorific value at constant volume required for any particular moisture content basis is derived from the following equation. The result shall be reported to the nearest multiple of 10 joules per gram with unambiguous statements concerning the state's constant volume, gross, and moisture basis.